Hello everyone, I'm Xiaogang. Okay, in the last lesson, we talked about this warehouse component. I wonder if you felt a bit dizzy. Right? Let's slowly keep writing it down. First of all, we come here. In this lesson, we will mainly write the UI logic. Let me find it. Here, we need to prepare a slot base. What does this slot base do? It mainly defines the logic displayed on the UI. It is actually the part of the logic in the blueprint graph. We will write it in C++ code. Okay, so for this slot base, we also need to write a few more things here because there is quite a lot. This information described is used for creating the detail box. The detail box. This is the detail box. And what is this? The one above is used for dragging. We use a drag and drop class. After we finish writing it like this, we first write this slot base. So first of all, we first include these basic things. Include the reflection file, then for a slate. Definitely for a slate. We need an image and a button, because this button must be clickable, and also an image to show what it is. Then next we will create it. Okay? This is the button we want to create. Then this points to the image we want to display. This points to a box of images. And here we need to bind it in Blueprint. Then here we need a button. We need to bind the click event to this button. Then we have a tip class. This tip class will point to the class we want to generate. That describes it accordingly. Okay, next is our construct and tick functions. Actually, we don't even need the tick. We don't need this tick function. We do need the construct, because inside it, we need to bind the button's event. Then we need to prepare two functions to expand and show. That is to hide and show this widget, because we may sometimes need to hide it. For example, we need to hide it when dragging. This function retrieves the current prompt slot, such a widget. Then when we click, then we have a button. Here we will prepare a function to bind the button event. And here we also prepared a slot type. What is this slot type for? It is mainly used to help us distinguish which slot the current slot belongs to, because this slot might belong to the skill panel, the backpack panel, the equipment panel. We simply assign one per session. Let it create a transfer order atmosphere. Okay, now let's do it all at once. Let's implement it step by step. And this is a constructor for slot. Then inside the constructor, we first call the parent class. Then we set our type, initialize it back to the lounge type. Of course, right now we don't know what it is. Then next is this constructor, the relative constructor. Its purpose is mainly that we remember to call the parent class. Must drop the compound type. If it doesn't drop this thing of yours, your point. The series of work we do later may not take effect, like clicking top. Here we need to bind this click action of ours, and this action is currently empty because this is just an interface. Actually, as for the show and head button here, we can write it. The logic here, it actually just calls this icon directly. Calls this imagine. We can just set its ability directly. So this slot icon is actually here. That is its slot icon. And the more troublesome part is the slot tip function. This part needs to return a view gate. Returns a UMG. So for this UMG, you need to initialize the relevant information inside this UMG. So we provide the one here. We need to create this thing here. As for this thing, I'll just leave it. We don't need to write anything. You can write it here. That is what is the level of this equipment. What is the price? And what are its features? For example, what triggers it? Blah blah blah. A bunch of features and such. That's all fine. We won't write it here. Then, if you want to display this feature in the slot, then here, for the description class you defined, you just need to assign values to its parameters. I think the friends watching here should be pretty comfortable with this. As for this class, if it exists, then we use car yt, then create one, then process this information properly, then just return it back. Okay, so basically our slot bits is ready for everyone. Now let's compile it. It should be fine. This is our slot base. With the slot base, we can then write our union lotus slot, because later on here it prompts that there is no constructor, meaning it actually doesn't include the header file because it doesn't know what this is. We'll just stick it like this. Let's compile it again. This is our slow base. Our remaining equipment slots and backpack slots will all be replaced with it. Then here we'll assign these classes. Give the names some color. These classes will actually involve writing a lot of code. If you've ever made a backpack in Blueprint, you'll find it's really quite troublesome. But if you write it in C++, the logic is clearer. Variables and such are also relatively more convenient. Okay, let's do it together here. Let's finish the equipment part as well. But we can't write the equipment yet, because equipment is very complex, because their logic has to be mixed with this. Good. Okay, let me brush it first. Good. I've already brushed it a bit. Hopefully there won't be too many red lines this time. First, let's include this minimal dependency here. Then here we include our UI-related stuff. We don't need to include it here. UA bus, we include slows base. This is our equipment. This slow slot, this is not equipment. This inventory backpack, that slow slot. Then, on our side, because we might need to handle an event of this button, so we need to include the fHandle of button, something like reply. Then we include the reflection file and this text box. Okay, then for this UI, first, you must specify when it is being dragged, which drag class is being used. So here we are. There is a drag class, such a variable. We will use it later. For example, here, it needs to specify this type, so we put it here. And first of all, this constructor, right. And then next is our inventory in the pair. It definitely has an ID. That is, which slot it is in the backpack, and also how many of it are left now. Okay. Then we have a few methods here. We may need to rewrite it. These methods are triggered when the mouse is pressed down on it. It will trigger these methods. Paste it. When we drag, we also need to handle it with such methods. Let's not write these three methods for now. Let's not write the drag for now. Delete it, because mixing them together here's a bit troublesome. Writing it, okay. So now we'll just rewrite these methods for it. These methods mainly hide our number, because when we don't have it, we don't want this number to exist, right? Then here we have when we activate it, when we click, this method should be collected. Widget. So when we click, we need to trigger. This method is the overridden method. You see this overridden method. Okay, then it doesn't need to be marked in red anymore because it's directly overridden. Okay, so simply put, this is one of our slots. Slot like this. Okay, next, let's write its constructor function. In the constructor function, we first call the parent class. Then we need to set its slot type. I find the slot type of the parent class. It is currently an inventory slot. And we need to include the header file here. First, we may need to include the drag class. We haven't written the drag class yet, have we? Let's write the drag class first. It's relatively simple. We'll just paste it directly. It actually only has one icon. When you drag it, there will be a frame on the right side of your mouse to display this image. Okay, we'll just write it like this. You can display more information. That's completely fine. Then when dragging, we provide a method for this drag icon. We pass a texture to it. Pass the texture in. I can then set it. That's all it needs. Then we go back to our inventory slot. At this point, it should no longer report errors. Then we'll handle these header files here. This header file handles dragging. This will be needed when dragging the word. We haven't written the word dragging yet. We'll write it later. As for this character here, we should be using it. And then for our several compound ones, these backticks, you can change them to quotation marks. It looks better this way. These backticks might be because when I was using UMG before, its auto import would use these backticks, and we still need to include this equipment one, even though there's nothing written in it yet, because when we drag, you'll be interaction between the two. Then regarding the definition of this equipment, we also need to include it. And the corresponding components also need to be included. Okay, alright. Next, let's continue moving forward. For the last method we have left, it's these final two methods. We need to hide this inventory number. Alright, so for hiding it, we actually just need to set the numbers. Visibility directly. Alright, next is our click method. When you are on the client, because this is clicked on the client, but the function it triggers must be implemented on the server. So first we still need to get our AC2R. After getting the AC2R, we might need an RPC here to implement this related functionality. Let's put it in C. Where is the best place to put it? Let's put it here. We'll give it a new method. We'll name it server. It should be reliable, meaning it should be reliable. Wait a moment, let me find this signature. Oh, it's right here, isn't it? It's right here? Okay, then, as for his signature, it's actually called this. This is activity score by inventory ID. That is, we pass in this ID, and then we activate the corresponding function. So how does it work? We create its implementation. Okay, note that for this implementation, we must add the back array. Because it goes over RPC, it's implemented on the server side. And you are already on this server now. So you just need to check. There seems to be an error here. It should be fine though. Let's check. Let's compile it first to make sure it doesn't report errors. Reporting an error is a bit strange. Okay, obviously this is a false red line. Let's just ignore it. Here we need to get our component. As for this component, we can just do it this way. Because it's definitely on the server now. Does this place not include an inventory component? It should be included. Then just ignore it. After including this component, inside this component, we will write such a method. This is a very important method. We'll put it at the very top. Then it's the inventory by scale. This can only be triggered on the server. We won't include it in the blueprint. Then we come to our character here. We just needed to call this method. Okay, then let's see how we should write this. Let me think. Here, the writing here is actually quite complex. First, I need to determine whether this thing is usable. If it's not usable, then it proves it's no good. Secondly, we need to determine whether the class it currently points to is a potential. If the class it currently points to is a potential, if it's a potential in our repository, then we can proceed forward. If not, we determine whether it is pointing to a backpack. Here, we then determine whether it is equipment. These two logics are different because equipment is private memory, and this portion is registered as GA and used. Then at this point, We are here. We can get the ability system component. After getting this component, we can get the gameplay ability we are pointing to. Then here, we register it. We register it here. After registration, let's try to activate it. Then after it is activated, we give it something like this. That is, we let it automatically remove this ability. This can actually be placed earlier. You can see what this function is. We can take a look at its function signature. Right here. That is, when this ability is completed, activate it. If it is not activated now, once. As for this thing, that is, anyway, just remove it. Actually, it should be placed later here. That's the correct way. Actually, this try activity, you can take a look. It can provide some methods. You can see here, try activity. Actually, when it registers, there is a point during registration that activates it immediately. Let's see if we can find this method. Show it to them. It should be in this context. You can see here, it gives me ability and an active want. Good. Okay, then this ability of ours, because it is initiated on the server, we will not do local prediction for this ability. Good. So this is how we activate it. The ability corresponding to this level. Okay, then let's go back to our inventory story. This took a long detour. Just click normally on the client. After clicking is done, let's check the activity here. It should be this function. Okay, let's click into this inventory's inventory ID. Let's see if this will report an error. Okay, this function is the inventory's function. It is protected. Let's take a look. So here we move it. Move it up here. Let's put it in this position. Then this should be fine. Go back to our union pores. Now it works. When clicking on the client, we use the character class to relay. Send one RPC. After sending this RPC to the RPC, we are on the server. We use RPC. We operate our components on the server. After operating this component, after activation is complete, then this thing, it will update the situation in the warehouse. We update it through GA. Okay, then GA needs to be written in Blueprint. We won't worry about that for now. Then our inventory slot. Let's process it like this first. Then let's run it now, our inventory panel thing. So this thing is mainly for making a container to materialize each inventory slot. Then here we include the header file. Note, here we include this UniformGridPanel. This container is actually the same as a horizontal box or a vertical box in UMG, but it's uniform, so it can be more standardized. Okay, then include the reflection file. Then we need to forward declare our slot. Next, we will define the UMG we need to use. Okay, first of all, we definitely have a container frame. It is handled by the inventory array. Then we need to configure what the current slot looks like. Next, we will take some default methods and simply restart them. Generally, we have these three methods. We have pasted them here. Then we will prepare a method here to receive our warehouse component and trigger the inventory thing. So now let's implement it. Now we need to create its implementations. Okay. In this constructor, we first call the parent class constructor. We must call it because it's often missed. Then we directly get our warehouse component. Then we just bind it directly. And here we need to include the header file. Right. Include the character class and our backpack slot and the corresponding magic or ticks that might be needed and our warehouse component. This way, we can smoothly bind this thing. Then after we finish binding, actually, it's better to write a method here to let it actively request So let's leave it blank for now, because if after you finish binding, depending on the timing of synchronization, if you miss the synchronization timing, you might not be able to correctly get the initial data. You might need to perform an operation before you can do it. So here we can do one active, the operation that makes it actively request a server update. Server. Yes, that is, you make the server actively update this backpack. Make the server actively send this backpack data once. This can be done here. Okay, when absorbing purchasing, remember to unbind the corresponding thing. Okay, because it is a single broadcast, you can just unbind it yourself. As for tick, we have nothing to do. Okay, here, after we finish this binding, we usually receive this, an inventory method at the 1000 level. Then we can proactively request it once here. So we write it like this here. We get our character. First, we definitely need to jump to the server. After jumping to the server, we need to have it proactively sending again the data in this warehouse. Let's just write it like this here. A bit noisy. We'll call it call server download. Download latest. Let's just call it download him. Okay, let's name it this method. So we don't have this method yet because it doesn't require parameters. Let's go to our counter class. Let's write them together. Simply, let's write it here. Okay, then at this point, we can jump to our server. Okay, then what do we do here? We get our, there's a missing semicolon here. Then we get our inventory. Let's write another method here. For this method, let's call it an ARPG method. So our method uses this. Let's use this name for our method. Still use this name. Let's write it here. But this method of yours, if it is not called correctly, it should be discarded or not take effect. So we call this through the component core server download info, and here we need to prepare an RPC. The name of this RPC is this. So this name is called inventory change. This is essentially something executed on the client side. Let's call it. Then it calls on this side. The parameters it passes are these parameters on our server. This parameter on the server. Then when it executes, it's also relatively simple. It's just that you deduct and execute it on the client. Its binding is done. Okay, here, then let's check if our synchronization method has been written inside the synchronization method. It should also be like this. Okay, so this part is a bit confusing. Everyone should understand clearly. We first jump to the server. Then the server jumps back to this client. So this is the operational flow. Now let's go back to our panel. Okay, so at the very beginning, we make it perform this request task. Then when we receive this update sent from the server, we start to update our data. So I'll just write them together here. And if it's our first time entering, then there should be no UMG here. That is, when we first enter, we have no UMG. And at this point, first, we need to create it. As for this creation, it's actually quite simple. We'll do 2 for loops. Then we have 5 rows and 6 columns. Just loop through it like this. Then we create a vgate. And then create this vgate into our container. Add it as its child object. At the same time, we need to give it an inventory ID. Since we are creating them all at once, it will be from 0 to 29. This way, we can make a correspondence. Okay, so after the correspondence is done, if it is only during the first creation, then after the first creation is complete, we need to update the elements inside. At that point, it should be greater than 0 to 3 because it has already been created, right? Okay, once you've created it, then we can start the for loop. We retrieve our data one by one. It is easy to miss these parentheses here. Let's add all the missing parentheses. Okay, and now we go from 0 to 29. We will temporarily retrieve the data from the array managed by our ship. Now we will take this data and first extract the slot. After extracting it, we check the data in the array. If there is data in the array, we update it. If there is no data, we hide it. This piece of code is actually quite easy to write. Then here we get our array and map it to this slot. Then if it is easewire, it means it points to a specific asset. Then we just need to set our quantity. Turn on its visibility, just update the image, and it will be fine. If it doesn't exist, then we can just hide it. Right, okay. After doing this, actually our warehouse component is now ready for everyone. It's quite complex, and we still have some drag and drop to do. We'll do it later, because it's already over 20 minutes. Okay, let's check what the error is here. This place probably doesn't have this implementation. I think because it's an RPC. Let's check it here. Do we have this implementation here? And this should also need to be done. An implementation of this inventory, because it is also an RPC. The main thing here is that RPC must be implemented. Okay. Then in the next lesson, we will configure the difficulty resources for you. Then we can effectively demonstrate this thing.